Welcome. We're so excited to have you here with us for this talk. Let me give this to Adviti.
Thank you.
We're so excited to have you here. We're really excited about this topic. Thank you to Jenny for the introduction. Again, I'm Jameis Buck at MongoDB. I've been at MongoDB for almost 2 years, and I've been working with Ruby professionally for about 20.
Hello, I'm Adviti. I've been working with Ruby professionally for 2 months, which is not as much as 20 years. But I learned Ruby this past summer while interning at MongoDB, while working on this project, Flattening Recursion with Fibers, and I'm super excited to present this with Jameis.
Wonderful.
Thank you.
Thank you. Thank you. So for about the next 20 minutes or so, we will be regaling you with a tale in 3 acts of success and failure, hope and despair, and ultimate victory. So buckle your seatbelts and hang on, because it's going to be a little bit of a roller coaster.
So let's start with our first act amongst our one index list of acts, Act 1, in which our hero encounters a monster. Once upon a time, there was a village of happy villagers. Some of the villagers, like this one in the middle, had 4 children. They wanted to live in an egalitarian society where whenever the parents prosper, the children should have the right to prosper as well. In order to codify their laws, they hire RubyDB, a friendly neighborhood Ruby developer.
So RubyDB is a bit of a practical, pragmatic fellow. Rather than inventing everything from scratch, he reached for what was familiar and already present. And so he decided to use active model as the basis for his framework. So this will look very familiar to Rails programmers. Active model was mature, it's familiar, and it does almost everything that he needs. One of the things it did not do is it doesn't support embedded documents. Embedded documents are records that are actually physically nested inside of other records. Has anyone here played with MongoDB before? Raise your hands. A few of you, that's awesome. Okay, so those of you who raise your hands, you might be familiar with embedded documents. But that is one of the things that RubyDB needed in his framework. And so he knew he was going to have to implement a little bit extra. Honestly, active model still did almost everything that he needed. The biggest special case that he encountered was with callbacks. Because the callbacks on these embedded records, there's a thing called cascading callbacks, which is a situation where when an operation hits, or when an operation happens on the parent, you want the callbacks to filter down through to the children as well. So in this example, when the parent is saved, RubyDB wants this do something callback to also be invoked on each of the children as well. So that's not too bad. That wasn't too bad. But around callbacks make this a little more complicated because they're recursive in nature, right? You can't just call them in sequence. You have to nest them together, and that gets a little tricky. If you're not familiar, I suppose most of you probably are, but if you're not familiar with around callbacks, the idea is that when something happens, like a save, this around callback is called and begins executing, and then that yield in the middle returns control back to the calling operation so that it can finish. So for instance, saving, and when the save is finished, it comes back to this method and completes. So it's not as straightforward as a simple before and after callback. So this is RubyDB's first attempt, right? We're gonna deal with just save for now, but given a save operation, he's going to call this run embedded callbacks method. And it's gonna take a block that's going to encapsulate the core functionality of the save. In this case, that really actually save method is going to save the top level record in this hierarchy of embedded documents. So run embedded callbacks itself, his first naive attempt, it just iterates over all of the children in the list, calls run callbacks on each of them, and yields to the block. Except that's really not what he wants for 2 reasons. The first reason is that if there are no children, nothing happens, right? If there's no children, that block is never yielded to, the parent is never persisted, chaos reigns, everything falls apart, world ends, etc. Also, because this is happening for each child, he's now invoking that block. If there's 10 children, he's invoking that block 10 times. He's saving the top level document 10 times, and that is definitely not the intent. So he has to go back to the drawing board a little bit. This is what he came up with then. This is the recursive implementation. Anyone that's done much with like Lisp or any of those functional languages will be familiar with this idiom for iterating over a list. If the list is empty, if there's no children, he just immediately yields and returns. That ensures that the meat of the operation is accomplished regardless of how many children there are. Then he splits the list. He takes the head, which is the first element of the list, and the tail, which is the rest. And he runs the callbacks on the head. Within that block is the piece that will be invoked between before and after callbacks and in the middle of around callbacks. So within that block, he's going to check first to see, are there any more elements in the list, or is the tail empty? If the tail's empty, that means the list has finished processing and there's nothing left to do. So we yield, and that's the end. If there's more elements in that list, if the tail is not empty, we're going to run embedded callbacks again, recursively on the tail to ensure that everything gets done. So I'm going to pause for just a second, make sure that you can convince yourselves that this truly does cover the entire list and that it's recursive. Does anyone have any questions right now about what we're doing here? Okay, the hardest thing about public speaking when you're asking a question is the waiting. I've heard you're supposed to count to 7 after you ask a question. I tell you, that is the longest 7 seconds you will ever experience. So it works. RubyDB takes a deep breath, sigh of relief, basks in the glow of the contentment of a job well done, watches as the villagers and the children prosper together. Life is good.
Inspired by RubyDB's work, one of the villagers decides to adopt 1,000 children. There's always that one guy. I know what you're thinking. That's a lot of children. Surprisingly, what happens is that the villagers are encountered by a terrible system stack error that arises from the depths of the call stack, threatens the village, and makes RubyDB sweat in anxiety. Now I would encourage all of you to take a minute to think about why the system stack error occurs. Or if you don't want to think about that, you can also appreciate the jokes that I came up with on the slide. Here's the implementation as a refresher. And like Jameis, I'm also going to count 7 Mississippis. Okay, as Jameis explained, this is a recursive function where run embedded callbacks is called for each and every child document. When you have a lot of child documents, what happens is that the call stacks add up and lead to the stack space being exhausted, even though this is technically not a case of infinite recursion.
So, with the system stack error beast looming over the village, RubyDB desperately tries to build a wall to keep it out, to protect the villagers. He's building this wall, he's panicking, children are screaming, villagers are screaming, crying, running madly around, and all that RubyDB can think is, how did everything go so wrong? We encountered this very situation, well, minus the screaming villagers, in Mongoid, okay, which is our active record for MongoDB. With the embedded children, one of our users somehow had more than 1,000 embedded records in a single record with callbacks, with around call, or actually it wasn't even with around, but anyway, with callbacks, and it caused the stack to explode. And so we had to go and investigate that, figure out what was going on. And ultimately, instead of a nice clean solution, and we all know what it's like to be under pressure with other priorities. We didn't have the time or the resources available to research this, so we had to just backlog it. We implemented a flag that basically disabled around callbacks for embedded children. Not an elegant solution. RubyDuby is obviously not happy with it. You can tell by that little grimace on his face. This is not elegant. The villagers are safe, the children are safe, but they've sacrificed some of their freedoms, and the parents and the children can no longer be guaranteed to prosper equally.
The lack of time and resources that James mentioned were provided by me, an intern this past summer, dealing with this project. But here's Act 2, in which our hero embarks on a side quest to linearize the problematic recursive call stack, which is a really long way of saying, recursion doesn't work, fix it. On a quest to find an alternate implementation, RubyDuby encounters a mysterious artifact made of long fibers, never forged for this specific battle, but carrying great hope with it. Inspired to learn as much as he could about this mysterious artifact, he reads a mysterious scripture accompanying it titled docs.ruby-lang.org. While studying the scriptures, he learns that fibers are a concurrency primitive where the programmers have control over when a fiber can be paused or resumed. The fiber.new method is used to instantiate a fiber with a code block, while the fiber.resume method is used to resume the execution of the code block that the fiber was instantiated with. In this example, we create a fiber instantiated with a code block that prints "Dare we hope," and calling fiber.resume resumes the execution of this code block, thus printing "Dare we hope." For a more substantial example, here we create a fiber that's instantiated with a code block that prints "start," calls fiber.yield, and prints "finish." The fiber.yield method can be used to pause the execution of a block while we do some other work, and then resume the execution of the block later on, kind of like an around filter. So in this example, the first fiber.resume starts executing the code block that prints "start." When fiber.yield is encountered, control is returned back to the second fiber.resume that again resumes the execution of the code block, printing "finish." Now let's consider an even more involved example. Over here, we have 4 different functions: foo, bar, baz, and bang. Here we're creating 4 levels of nested blocks. And what happens is that when foo is invoked, it prints enter foo. The yield statement yields to the code block passed into it that calls bar, printing enter bar, and so on and so forth until done is printed. After that, exit bang, exit baz, exit bar, and exit foo are printed. These nested blocks simulate the nested nature of the recursion that RubyDuby encountered. And his main goal was to try and linearize this somehow using fibers. So what RubyDuby did was that he created a fiber for each and every function. And that's what the fibers equals whatever .map function does. It essentially creates a fiber for foo, bar, baz, and bang, where the code block simply invokes the function, passing into it a code block that calls fiber.yield. So what fibers.eachResume does is that it first resumes the fiber for the foo function that invokes foo, printing enter foo, and once foo yields to the code block, fiber.yield is invoked, which returns control to the fibers.each line that goes on to do the same thing for bar, baz, and bang, thus printing enter foo, enter bar, enter baz, enter bang. Then puts done is encountered, which prints done. Fibers.reverse each resume similarly resumes all the fibers, but from bang all the way back to foo, thus printing exit bang, exit baz, exit bar, and exit foo. Wow, that was difficult to say. And as you can see, the output on this slide was the same as the output on the previous slide. And RubyDuby kind of linearized the recursive nature of nested blocks. And the key ingredient was obviously the fiber.yield that was passed into the function that was invoked for each of the 4 functions. Once again, I'm going to pause for maybe a minute for any questions you may have, because we know this is a lot to digest. I did this over the course of 2 months. We have 20 minutes with you all. Yes.
Yes, question right here.
Hold
on 1 second, let's get a mic to you.
So that this approach linearizes the It linearizes the recursion, but it doesn't fix the problem.
It doesn't fix the problem.
Does it not fix the problem? Yeah, because it doesn't look like this would avoid the stack space error. That's my.
The thing is, the fibers are no longer created on the stack. You're right, there's still memory use. The use is still the same, in fact, but now it's being put on the heap as separate fibers as opposed to being pushed onto a single stack. Okay, good point, good point.
That's a great question. Thank you.
One more question over here.
Oh, sorry.
What about the previous recursion was keeping something on the stack? I didn't understand that bit. Like you weren't consuming in place, right? So you must have been keeping something on the stack.
So you're asking how? Or no, go to the foobar baz nested.
Yeah, in the original problem.
Oh,
not
for
here.
The original
like in
problem.
the original one where you were trying
well,
to save the children. I didn't understand because it looked to me like you were doing the recursive call at the end, and so naively I'm trying to think about like what's being kept on the stack that's not being.
Go forward to the solution right there.
Yep.
That one?
Yes. Yeah.
Okay, so yeah, the key to the recursion is that call inside the block to run embedded callbacks. So it's calling itself, and every time it calls itself, it pushes a frame onto the stack to keep track of where it was when it needs to return from that function. Does that make sense?
Yes.
Okay, and so if we have 1,000 children, it's going to push onto that stack each time we recurse on that.
Okay, fair enough.
Does that make sense? Am I misunderstanding the question?
No, you answered it. I have more questions, but I'll follow up with them later or something.
Okay, we'll do more questions at the end of the presentation
great.
as well, okay? Great.
Thank you.
Right there? Okay, so things are looking pretty good. This recursive algorithm has been flattened to a linear algorithm. We've taken care of the problem with the stack space being exhausted. It's all being put on the heap now. So theoretically, we can go for as deeply as we need to without worrying about exhausting the stack because the stack is no longer being consumed for each child. Things look good. Unfortunately, in theory, there's no difference between theory and practice, but in practice there is. So RubyDB is armed with this new weapon. He's tried it out in a sandbox and it looks really promising, but now here he is standing in front of this beast armed with this new weapon and he's like, where do I start? What am I supposed to do? Does he need to put this in active record, the callback system? If so, where? Like, I don't know if any of you have actually looked at active support callbacks, but there's a lot of code there. And it's non-trivial. Like it does a lot of optimizations. There's a lot of different pieces. Does this need to go in call template method call? Does this need to go in callbacks run callbacks? Does it belong in Rails at all? Because again, this was intended to fix the problem with embedded children, embedded documents, which is not something that active record even supports. So if it doesn't belong in Rails, do we extract this as a plugin? But that still leaves us with the same problem, right? Even if it's a plugin, we still need to figure out what we patch and where it goes. It's terrible. Our hero is faced with this new bugbear of complexity that has snatched victory right at the moment when he felt like it was there. And he despairs.
As someone who learned Ruby and Ruby on Rails for 2 weeks before diving into this project, I can relate with the fact that the hero did despair a lot. And that brings us to Act 3, in which the beast is finally vanquished. The hero's melancholy was bottomless. He decides to go on the walk on the other side of the village, whose hill looks exactly like the hill on the first few slides, but symmetrically opposite, because again, I'm in computer science, I'm not an artist. While going on this walk and touching much needed grass, he is struck with the lightning of inspiration. And he realizes, instead of touching Rails, why don't we just drop fiber.yield within Mongoid itself? So this is what RubyDB came up with. What he does is that for each child document, he creates a fiber that's instantiated with a code block that calls run callbacks on that child document, passing into it fiber.yield. If you make comparisons with the foo-bar baz example earlier, this is structurally similar to that. What the fibers.each resume line does is, again, it sequentially goes through the fibers of all the child documents and calls run callbacks on it. So for the first child document, the run callbacks would run the before callbacks and the first part of the around callbacks, do that for all the children in the list, then yield to the code block pass into run embedded callbacks, and then do the same thing in reverse. So it would, for the last child, execute the second half of its around callbacks and the after callbacks, all the way up to the first child.
And miraculously, it works. What a wild, crazy idea. Something like, it's not even intended for this purpose. It's a concurrency primitive, right? And yet here, it actually works. And our hero takes a deep breath of relief, feels miraculously saved. Go ahead to the next one.
Oh, I don't know
what
happened.
did you do? Okay.
I got a lot of that this past summer.
And now the villagers can have as many children as they want, right? 1,000, 10,000. The only limit now is the size of their house, right? Or maybe the village or whatever. But RubyDuby gleefully tears down that wall. The villagers are now free to run about. They've regained all of their freedom. Parents and children are able to prosper together. There's feasting and fireworks. There's celebration, dancing in the streets. Everything is great and life is good. And they live happily ever after until the next beast eventually rears its ugly head. Because as we all know, there's always another beast. So thank you very much.
Find us afterward for free socks and stickers. The socks are really nice. We're wearing them right now. Yeah, and we'd love to answer any questions you may have. You can also chat with us thereafter.
Yes, question over here.
So at a meta level, this is specifically an issue where you have code that you need to call that you don't control that yields in the middle of it. And that's the reason why. So like, for example, for like a before callbacks thing, this would be a non-issue. You could stick lambdas around it and you'd be fine. So this is specifically for you need to pass it a block, and fibers allow you to pause at any point in time in the middle of the execution and then resume it later. And that's why you're using fibers here, right?
That is correct. That was almost not a question, but you saved yourself at the very end. Good job.
Okay, cool. No, I just wanted to make sure that I like understood the use of this.
Yes,
it's
exactly.
a pretty cool use.
It's pretty niche, but it was exactly what we needed here.
Cool.
Yes.
We have
Question
two
right here.
questions.
Oh, two questions.
One and two.
Arm wrestle.
Wow, I feel popular for once.
Quick question. Is it something about fibers, or is it just that fibers give you that ability to resume twice, and you know, or is it anything specific to fibers?
Honestly, in this case, it was just that it allowed us to interrupt in the middle and then resume them on our own schedule. So yes, it could have been anything. It just happened to be a concurrency primitive that did the job for us.
Yeah, and I think like around callbacks is what makes this more complicated, because around callbacks require like your run callbacks to yield to the code block passed in, and so on and so forth. That's a great question.
The initial problem statement looked like it could have been solved by iterating over the children.
You want to go back
I
to
didn't
that slide?
see in that original one code that needed to be executed before and after.
Okay, so yeah, let's get back to that statement here. This one. This was RubyDuby's first try, iterating over the children, right? So there were two problems here.
The next one.
Oh, the next one. Okay. Yes. Okay. So again, what's the? Can you restate your question about this one?
Okay. Oh, sorry. this looks, what would happen if you iterated over each of the children, running callbacks, and then yielding?
So if we go back to the previous slide, oops, we're chasing each other here. Ah.
Okay, you got it.
I'll just do it. Okay, so that's kind of what we're doing here, but we can't yield outside of that iteration because run callbacks has a block that yields.
That's blocked.
The constraint is the Rails API that we're dealing with here that we don't have a lot of control over because the Rails API needs to support around callbacks, which are yield-based.
That was the part I was missing.
Does that make sense? Okay,
Yeah, thank you.
great, great. Right behind you, Jenny.
I'm curious about the creative process behind arriving at this solution, because it's so infrequently the case that, you know, you take a primitive with that's like very purpose built, and using it in a different application is like, it's often a disaster. In this case, I would say it's, you know, completely the right choice.
Mm-hmm.
So how do you unlock your thinking and reach, you know, this right solution?
Okay,
that's
so
rarely the case.
James, do you want to talk about like the proof of concept, and then I can talk about how it fit in?
Perfect, that's just what I was thinking too. So there were two parts to this. Before Adviti came on for her internship, I kind of had the brainstorm that fibers might work. And it happened because I've played with fibers. I knew conceptually what they were and how they worked, and I knew that fiber yield basically lets you pause in the middle. And so taking that knowledge, and after thinking deeply about the problem that we had, where I was like, we need to somehow linearize this, right? Like remove the recursive aspects so that we don't recurse and overflow the stack. And so as I was thinking about it, I was like, I wish there was some way as we're executing this to stop and save it so that we can then put it aside and then do the same thing for the next one, right? So you're like going this far, putting it aside, this far, putting it aside. And that's where I was like, well, that's kind of like stopping a block in the middle, which isn't that what fibers do? And so I wrote a simple proof of concept, which is equivalent to Ruby Dooby's like wielding his weapon in practice, in theory. And it seemed to have promise. It seemed like it would work. But again, I didn't have the time or the space to actually work on it. I had to stop. And then Adviti came for her internship, and I was like, I know what we can make her do.
Yeah, working on this project was incredibly fun. The way that I approached it was, I obviously was exposed to Ruby for the first time, so I tried to get onboarded. But then I tried to understand how callbacks worked at the level of active support in Rails. So I went through like the entire file function by function, trying to understand like key factors behind the decision-making process, behind the design process. And I did the same for MongoDB as well. And the key part that I had to figure out was where exactly could fibers play a part. It could either play a part at some point within the like the callback implementation of active support or within MongoDB itself. But James and I were pretty confident that it would most probably be in Ruby on Rails. So for each and every point, I came up with like multiple proof of concepts, tried to figure it out on pen and paper if it worked. And ultimately, I went all the way up to MongoDB and then realized that the solution lay there all along. So it was a very iterative process. And another thing that helped me was taking this leap of faith that we take in Recursion, where you trust that calling the function returns the right answer. I kind of trusted that Ruby on Rails was implemented as efficiently as possible, given that the file was like touched around 12 to 13 years ago. And then we just like used whatever they had and made changes on our end, which let our solution be very concise.
And she actually touched grass to figure it out. So I'm getting the signal, we're done. Thank you so much. If you have more questions, please do find us afterward. And also, please do come find us for some socks and stickers. Thank you very much.
Thank you.